So, we all know the plot behind the Christmas movie Home Alone, right? Home Alone is a brutal movie that involves a violently inclined kid named Kevin who likes to cause great pain to two random guys, Harry and Marv, just want to take a few things from his house. Like in this clip, for example, where Kevin causes Harry and Marv to ram into an actual brick wall high around 30 feet, or 9 meters in the metric system. Man, happens here look like it would hurt. It looks like it would break a bone if it happened in real life. If you look at the map though, it might actually be a little bit different. Do the calculations, you can see why. We know that 9.1 meters is the height of where they're hanging on the rope as they're climbing to get to Kevin in his treehouse. And we know the constant for gravity would be 9.8 meters per second, since that's the constant for gravity on Earth. We can assume that Harry in this scene weighs about 58 kilograms, since that's actually the amount his actor weighs in real life. Marv's actor weighs about 84 kilograms in real life if we apply that same logic. With them both hanging on the rope, they'll form a combined mass of 142 kilograms. We're able to find the gravitational potential energy they have when they're hanging onto this rope, which will end up being about 12,663.6 joules. And since energy should be conserved during the swing, we can put this value into the kinetic energy equation, which will give us the velocity they experienced before they hit the wall. The speed, if after we plug it all into the equation, they should be moving at a speed of 13.4 meters per second, which would create an impulse of 1,902.8 kilograms times meter per second. If the swing converting potential energy to kinetic energy lasts for around 3 seconds like it did in this clip, it would have to have a force of 634.3 newtons. The force actually needed to break a bone like ribs, according to Discovery.com, would be around 4,000 newtons. So even though it looked like it would hurt, and maybe even break a bone like his ribs, it looks like he'd still be able to walk away from this like he did in the movie, even though this might not be the case for all the traps that we see here.
I got a better idea. Come on.
Home Alone shares its fair share of dramatic scenes. One of the scenes that we chose is when Harry and Marv both get hit by paint buckets when they're fighting Kevin in his house. They both fall off the stairs, hit their heads, and stand right back up like nothing ever happened. I believe in real life, they would have had some type of head injury like a concussion or a broken nose. I mean, we see Harry, and he does lose one of his teeth, but he's lucky he only lost that. In the clip, the paint cans are 4.56 kilograms and are dropped at a height of 3.05 meters above the ground. When Harry and Marv are coming up the stairs to go fight Kevin, that's when they get hit by the paint cans. The gravity would be 9.81 meters per second, as it's a constant on Earth. The paint can then hits them because of the gravitational potential energy being converted to kinetic energy at this point. By multiplying the mass, the height, and the gravity together, we should get 136.3 joules for the energy in total. And since gravitational potential energy is equal to kinetic energy, we will use the kinetic energy equation to find the velocity. The velocity should equal 7.7 meters per second for the paint cans. Now to find the velocity, we will take the mass from the information that we gathered earlier, and then multiply them to find our impulse, which would sum up to 351.12 kilograms times meters per second. This would not break someone's nose, but it could knock a person unconscious. The article from biomedical.gov states that it takes a minimum of 70 to 120 joules to experience a concussion injury. So yes, it may not make a concussion for them, but it would absolutely hurt them for sure. And they might not walk away from this one without maybe a good, 5-day rest.
Another clip that demonstrates bad physics is from this scene where Harry gets propelled into the air after Marv jumps onto the other side of the seesaw Harry was on. In reality, Harry couldn't have been able to get launched that high into the air. It's already assumed that Marv weighs 84 kilograms, Harry weighs 58 kilograms, and gravity is 9.8 meters per second squared. In the movie, he is estimated to reach a height of around 20 feet or 6 meters based on the scene, meaning his initial velocity should be 10.84 meters per second. Using this kinematics equation. The velocity is then used to find out how much energy Harry needed for this to happen. Using the kinetic energy equation, it shows that he should have had 3,407.7 joules of energy. Finally, the height Marv must have fallen from to propel Harry this high can be found. Kinetic energy is equal to potential energy since energy was conserved. Marv transferred energy over to Harry after he jumped on the seesaw and propelled Harry, so potential energy is also 3,407.7 joules, and put into this equation. The calculations show that the height that Marv needed to fall from is 4.1 meters or 13.5 feet. In the movie, Marv only fell from a height of about 2 to 3 feet, which is less than a meter, to propel Harry, which shows that this scene does violate the laws of physics.